start with our session. Okay, before the GRPA, let's start with the PPA. Okay. Write a recursive function named triangular that accepts a positive integer n as argument and returns the sum of the first n positive integers. Okay, so the name of the function is triangular, but the actual work of this function is not related to the name. So we have to write one function that sums, that takes a number, let's say 5, and then it will give the sum of all the numbers till 5. Okay, so 5, 4, 3, 2, 1, it will sum all of that. Now, if you remember, in last session, I made a diagram to like explain this problem. Give me a second, I'll see if that diagram is still available and I'll share that. Okay, just the diagram is not available. Let me get the pen tab. Okay, so now what we need to do is the name of the function will be triangular. For our ease, let's just call it sum. Okay, so sum n. If the number is n, what it does is it will just give you the sum of n plus n minus 1 plus n minus 2 and plus dot 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 till 0. So this is what sum does. All right. Now we need to write this function. So if I write it like this, is it clear? Like, just tell me, is it correct if I write it like this? If I have a number n, right? I want the sum of all the numbers till n. So can I write it like this? N plus sum of n minus 1. So it will give me all the numbers till sum of all the numbers till n minus 1, and I'll just write. I'll just add n at the end. Right? It's clear.
Yes, sir.
So I'll keep doing this until the number is 0 or 1. The value of sum 0 will be the
0.
value of sum 0 is
0.
0 because there are no numbers to sum. So the value of sum 0 is 0. What is the value of sum 1? It will be 1 plus 0, right? Which is 1. The value of sum 2, the value of sum 2 will be 2 plus sum 1, right? Value of sum 3 will be 3 plus sum 2. So what happens is, if I call sum3, what it will do is it will just add 3 to the sum of n minus 1. And sum2, what it does, it will add 2 to sum n minus 1, which is sum 1. And the sum, this value is a constant. This is not a variable. This is a constant. So we know this value. So what we'll do is, now that we know this value, we will take this complete thing and then we'll add 2 plus 1, 3. So this will be 2 plus 1, 3. Now we'll take this value and keep it over here. So 3 plus 3 is 6. So this is what the flow will be. Now let's write the code for this. Okay. Now what do we need? If the number is n, we will do the same thing. We will return n plus, and we'll call the same function on n minus 1. Is this clear? Now, one problem is we have not written any stopping point in this. There's no stopping point. It will just keep on subtracting 1 from the n and just running the function over and over and over and over. There's no return point or there's no subtract point, stop point. So we'll need to add that. That is also called the base case. The base case is basically this, the value that we know. The value that we already know is the base case. So it can be either 0 or it can be either 1. We can take any of the two. Okay. So let's do that. So in this, before doing n plus triangular n minus 1, I'll check if n is equals 1. If n is equals 1, what is the value of triangular 1? It was 1. Correct? And if you want to write 0 over here, if you want to add 0 as the base case, you can change this to 0. That if n is equals 0, we will return 0. So both of these will work. 0 also works, and if I change this to 1, it will also work. Okay. So while solving a recursion problem, you just need to figure out two things, like what is the base case, or what is the return point, or what is the stop point. In this problem, it was n minus 1, or n equals 1, or n is equals 0. And the second thing is, how will you do this, right? How many calls, like how will you process the recursive calls? So this is the recursive call. Yeah, any issues in this problem?
No, sir.
Yeah, perfect.
Sir, I was wondering, like, one thing that in the normal in Python courses that we have studied, we have seen a break thing over here that breaks the function in the between.
Mm-hmm.
So, sir, I was wondering, like, if in this recursion process, if we put a break somewhere, like we have got some desired result, and we don't want to continue the recursion, can we put a break in the middle, like something like that?
No, we cannot do a break, because what break does is it will stop only one function, one particular function.
Okay.
Right? Let's say if we have a break over here, let's say if I have this, so this return is actually doing the work of break, right? In functions, if you want to break, right, we usually use return. We can use the break statement, but we usually use return. That if this is some case that we want to exit from the function, we just use the return statement. In
Okay,
functions,
sir.
we don't usually write break. Break is for breaking the loops, for loops or while loop.
So this recursion thing cannot be broken in between if once it starts, right? Is
If
it?
you want to break, you can use return. Just return
Okay.
from the statement.
Mhm.
Because break is used in loops, right?
Yes.
Now, next one is factorial. So factorial, I think, is very similar to this, right? Here, what we were doing 2 plus some of this. Like, let's see. So here, what we were doing? We were doing 2 plus sum of 1, 3 plus sum of 2, right? And then we'll just replace this with factorial because factorial is the same. How does factorial works? If I want to calculate 3 factorial, it is basically 3 into 2 into 1. Here we cannot take the base case as 0 because if we consider 0, it will make the whole product 0. If I want to calculate 4 factorial, so 4 factorial is basically 4 into 3 factorial. 5 factorial is 5 into 4 factorial. So we just need to do this. So try to do this one very quickly. Just complete this.
Yes, sir, done.
Yeah. If n equals 0, we return 1. Else, we return n into factorial of n minus 1. That is fine. N equals 0, we return 1. That is also fine. If n equals 1, then return 1. This is also fine. Now I'll just copy this and I'll paste it over. Now, one thing, when this factorial function you will actually use when you're doing lead code or solving any problems. So there is some edge cases that you need to consider as well. I don't think those edge cases will be covered over here, but you should know that if n is less than 0, right? If n is less than 0, then we just return. We don't do anything. We just return. Or actually, that depends on how you are handling the value. We can either return -1 or we can return 0, or we just return. We don't do anything if n is less than 0. Because let's say someone inputs minus 10 in the factorial function. We don't actually calculate the value for -10, right? Negative numbers has no factorial value. So if someone enters -10 in the factorial, we want to just return. We don't want to calculate. Because if we enter -10 in this factorial function, what will happen is it will check if n is equals 0, is n equals 0? No, it is not equals 0. It will return n into factorial of n minus 1. What is n minus 1? It will be minus 10 minus 1, which is minus 11. So minus 10 into minus 11, and it will just keep going.
So
So for
simply putting a return over here will end this procedure, right? Yes,
yeah, so
recursion.
what will happen, what basically happens is, if someone calculates negative factorial for a negative number, it will just return, it will not give any output. You can just copy this in Colab notebook and see how it works. Or we can just include this thing in this, that if n is less than equals to 0, we return 1. As I said, it depends on how the question is framed. How are we handling the negative values? In this question, we are not asked to handle negative values, so we can just do anything as we wish. We can just return this and add this, that if n is less than or equal to 0, we will return 1.
Sir, but in question it is mentioned positive integer, the factorial of positive
Yeah,
integer.
the factorial of a positive integer. Yeah, the question is mentioned. In this, it is mentioned. I am saying that this factorial is something you will use. Like if you continue coding, factorial function will uh, continuously, like many times, will be required to write the factorial function. So that's why I'm saying that this is one logical mistake that people actually do. They don't consider the negative numbers. Okay, let's move on to this. This is multiply. A recursive function to compute the product of two numbers. Write a recursive function named multiply that accepts two positive numbers a b as arguments and return their product. You can only use plus and minus operators. You are not allowed to use star symbol anywhere in your code. So this one is actually pretty interesting. You'll have to think how will you calculate the what is it, the product using only the plus and minus symbols. So any ideas?
Um,
We can add a b times.
Yeah, we can add a b times.
can
That is
return
one thing.
a comma b minus 1. When b equal to 0, it will return 0.
I don't get it. What you're trying to say? Can you please write it?
So we have to add a b times, no? So we'll return a comma b minus 1. When b equal to
A
0, it will
comma b
return.
minus one.
Yeah, it will return. That's the inductive step.
Yeah, please write it. I don't. Yes, yes, Gentle. Yes, 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 yes. Yeah, got it, got it. Can we use for loop until it reaches b and add? Yeah, that's the point. You're not. That's the point. You have to use recursion. You don't have to use for loops. That's the whole point, right? So this is the correct code. So what we do basically with this is, we have two numbers a and b, and we want to calculate the uh, product a multiplied by b basically. I cannot zoom out. Let's. Okay. So if you want the product a multiplied by b, what we can do is we can just do a plus a plus a plus a dot 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 b times b times. right? We can do this. So without using for loops, how will we know that we have come along b times? So what we do is, first we calculate the multiply of this. I'll just write I'll just write mul over here. Okay, give me a second please. Yeah, so we'll use this multiply of a plus b as the notation. Now what will we return? We will just do a plus, we'll write a plus, and then we have to multiply this b minus 1 times. Now if we are if we have taking 1a out, if we are taking 1a out of the series, this will be b minus 1 times. So now we do a plus mul of a comma b minus 1. And what this will do, this will just do a plus mul of a comma b minus 2. Let's say the value of a is 10 and let's say the value of b is 50. I'll change the color. Let's switch to this. So let's say the value of a is 10 and let's say the value of b is 5. So the product should be 50. We need to add 10 5 times. So what we do, we do 10 plus mul of 10 comma 4. So the initial call will be this mul of 10 comma 5. This is the initial call, and in this initial call we do 10 plus mul of 10 comma 4, and then inside this it will be 10 plus mul of 10 comma 3. So basically here we are saying that we need to add 10 5 times. So we take 110 out and then we add 10 4 times. Then we add 10 3 times. Then we add 10 2 times, and then once, only once. So now initially if we keep subtracting, we will reach b equals to 0 at some point. And if we reach b equals 0, we can just return 0. Or if we reach b equals 1, we can return the value of a. Whatever the value of a is, we can just return that. So this is what we are doing here. That if b is equals 0, we will return 0. Otherwise, we will just keep on adding a into multiply a comma b minus 1. Understood? Or any issues? Okay, I stopped sharing my screen by mistake. I'll share again. Now let's just submit this and see if this works. This works. Now let's move on to the next question. Now in this question we have log of x. Consider a positive integer x that is a power of 2. The logarithm of x to the base 2 is number of times 2 has to be multiplied with itself. So it's x and is denoted by log 2x. For example, log 24 is 2. Note that log 21 is 0. So in this we just have to like reverse the exponential function. Now tell me, how will you handle this? Anyone?
For every time we divide x by 2, we will add 1.
Yeah, we can do that. So do we need to find the square root? Not the square root actually. The log function basically finds this. So basically what happens is, if we have 2 and you, let's say I calculate 2 to the power 4, I'll get 16, right? So log 16 is this 4. So this exponential, we have to calculate this part. We'll get this number, we have to calculate this. Like what is the power of 2 to reach this number? Yeah. Yes. Well, your solution is correct, but there is one small mistake. Like, that is not a mistake, but yeah, we'll fix that. Yeah. So this is what Yash has wrote. What we do is, if x equals 1, we will return 0, because as mentioned, the value of log 1 is 0. My screen is stuck. Just give me a minute, okay? My screen is not working. Yeah, it's fine. Okay. So if x equals 1, the value will be 0. Otherwise, what we are doing, we are just calculating the log of x by 2. So basically this, if we want to calculate log of 16, we can just go 1 plus log of 8, right? Because 2 to the power 3 is 8 and 2 to the power 4 is 16. Now if you want to calculate log 8, it will be 1 plus log 4. So see, the input, the value of n is getting halved. So if this is n, this is n by 2, and this is n by 2 whole by 2. And if the value of this reaches 1, like it will be 1 plus log of this 4, this will be 2, because we are having the value, and in the next iteration it will be 1 plus log 1, and the value of log 1 is 0. It is mentioned in the question. So from here we will return 1. This 1 will go uh, here, and it will be added with this. So the cumulative value will be 2. Now this 2 will go over here. It will be added with this. So 1 plus 2. This will be 3, right? And then this 3 will jump on here. This will be 1 plus 3, which is 4, and so on. Okay, so that is what we are doing over here. And just so that we have integers, we will do this. so that we always have integers. Got it? Any issues with this question?
Sir, will it give answer for if we input x as a odd number?
Can you
Like
please come again?
like if we put x is equal to 9, will it give answer?
It will actually give you something, but it will not be the correct answer.
It is a float function.
Huh?
This x double 2, it will give an integer only.
Like, yeah, it will give you the integer. Always give you the integer. Okay, let's move on to the next question. This is a palindrome. So we have to write a recursive function to determine whether whether a string is palindrome or not. So palindrome is basically if all the letters are equal, we will just do palindrome.
Reverse correct.
Haha. Okay, I was not able to understand what they just said. Okay, now what the input will be words like this. Let me just take one word from the sample input. Let's say the word is mom, or let me just see any a big palindrome word. Just let's remove this and let's just write A B C D C B A. Okay, this is the palindrome. Is my screen visible? Yeah, it is visible. So
Yes,
this
sir.
is a palindrome. Now what we will do is we will just check that this part and this part, are these equal? If the start and the end is equal, we will now check the inner string. We'll just check this. Right, now for this string we will check, is this and this equal? So if this and this is equal, we will now check the another inner string. This and this is also equal. Now we'll only check this. So a fun fact is a one letter word or just the letter is always a palindrome. We consider it to be a palindrome. Okay, so this one is a palindrome. So since this is a palindrome, these two are palindromes, so we'll return true from over here. Okay, the flow will be basically, we will take one word. So first of all, let's say word, let's take the variable. Okay, so the first thing will be to determine the base case. When are we stopping? So we are only stopping when we have one letter left. right? So if you have only one letter left, we can just go this, that if length of word is equals 1, if the length of word is equals 1, we will return true, because a one letter is always a palindrome.
Yes, sir.
Right? Otherwise, the next condition will be to check this, that if the first letter, which is word 0, if this is equals word -1, if this thing is equal, then what we will do is, let's see, let's handle the equal case later. Let's first handle the unequal case, that if this is unequal, right? If these two letters are unequal at any point, then we'll directly return false. Because let's say this is equal, I'll change the color. Let's say this is equal, this is also equal, BB, and let's say this is D. This is not C, this is D. Not DD. This is D and this is C. So are these equal? They are not equal, right? So if anything is not equal to the corresponding letter to the right side, we'll just say that this word is not a palindrome. We don't need to check any further. We can just directly say that this is not a palindrome. So that's why we're doing this. That if word 0 and word -1, if these are not equal, we are returning false. And then if these are equal, we just need to pass in the inner string. So let's do that. Let's do that. Okay. So let's just handle the first case, that if length of word is equals 1, that if the length of the word is equals 1, we will return true, because one letter word is always a palindrome. Now if word 0 is not equals to word -1, if this is the case, we will return false. Otherwise, if word 0 is equals word -1, will return, will call the palindrome function and will pass in word from the first letter to the last letter, like from the second letter to the second last letter. Got it? And since we have the return condition over here, we can just ignore this as well. We don't need to write this, because it will only reach till this point if the word is not equal, like if the word is equal, if the letters are equal. Okay. So any doubts in this one? 7 out of 8 private tests pass. So one private test, we are failing one private test case. So what might that be? That if length of word is less than 1, we return true. If it is, then we check for the first and last letters, and then we jump onto that.
If
Sir,
the
if length is
string is
equal,
empty, then return false.
it's not even, nobody knows it better than you. You are not the one
Empty string?
forming the poster.
Are you talking about
You will
empty
just
string?
give them the description, okay? That okay, if it's a cricket one. I want the bat to be there. I want energetic, and it's
Yes. Someone was saying something.
So if you use that else case means that the if word of 0 is equal to word of -1,
Uh-huh.
then the private is passed or the private is passed.
Which one? Where?
Before the return, you have written that no line, just you remove that.
Which part are you like talking about? Which do you want me to remove?
No, no, you have
Sir, I
written.
was saying if it is an empty string, then
Yeah, we need to handle that. I think if we, let's say if we do this less than equals to, let's say this. Yeah, then 8 out of 8 pass. So one was in empty string. Someone else was saying something other than this.
Yes, sir. Empty string only. Same.
I'm even length.
Even length. Yes, even length. We need to handle even length. Yeah, we did not do this. So if length of word is 0, we return true. If length of word is this, we return false. Yeah, this will also pass all the cases. So what was happening? What's happening was this. We were missing this case. Let's say the word was of even length. Let's say A B B A. Let's say this is the word. So what was happening is this and this. These are equal. So we were passing this thing. This and this. These are also equal. So now we are passing word 1 to like, so word 1 till -1. So we are passing this now. So if we are passing this with this word, it will only give me this. So the length of this is 1. And this should work. I don't know why this is not working, but this should work. Basically, the word of length 0, right? Let's say the empty string. We'll also consider this a palindrome. If we consider this a palindrome, then it will work. Okay, the next one is spiral iterative and spiral recursive. So in the first one, we can use iterative function. Since this is an iterative function, we can use for loops and while loop or whatever loop you want. You can use in this one. Spiral recursive, we have to make a recursive function. So the question is, consider a spiral of semicircles. So this is a spiral. Like we have one semicircle, and after that we have one semicircle, then one, then one. So like that. Okay. Now we start at a point P naught on the x-axis with coordinates L0. So this is the part P naught L0. The first arm of the spiral ends at P1. So this is the first arm. It ends at P1, which is R0. So basically L0 is left 0, R0 is right 0. At P1 coordinates R0. the second arm of the spiral starts at P1 and ends at the center of the first arm. So now this starts at P1 and ends at center of this P0 to P1, the center of this, right? The center of these 2 points. The arm will be there. The third arm starts from P2 and ends at P3. The third arm starts at P2, ends at P3, which is the center of these two, P2 and P1, which happens to be the center of the second arm. And finally, the fourth arm starts at P3 and ends at P4, the center of the third arm. And then this ends at the center of this part. Leave this by. Okay. So now what we need to do is write a function name, write two functions name. I don't know why this is happening. I'm not able to scroll or do anything. My pointer is just not working. Just give me a second, okay?
Hello, sir.
Yeah.
Sir, can take a PPA 10?
PPA 10.
Yes, sir.
Yeah,
Because PPA 1 to 10 already discussed.
they are already discussed.
Yes, sir. Saturday class.
If they're already discussed in the Saturday session, then why did no one mention that in the Saturday session it was discussed? Okay, so if this is already discussed, we will not waste our time over this.
Yes, sir. Can take PPA 11.
PPA 11. So till PPA 10 it was discussed, right?
Yes, sir.
So then we'll start with PPA 11. Okay, so if you have any doubts in like any of these PPAs, please watch the previous session, because like doing all these 10 questions will just waste the time. Yeah, so let's do from PPA 11. So we write a function named insert that accepts a sorted list L of integers and an integer x as arguments. Okay, it should return a sorted list with element x inserted into the input list at the right place. Yeah. So this is basically, if you study DSA, data structures and algorithm, at any point, this you will encounter. So this is insertion sort. So what we do is we have a sorted list and we have a random number. So we just have to iterate over the list and we have to find the perfect place for that number to be inserted in. Okay, so I'll just share this and I'll tell you how we can do this. So let's say we have a list, a sorted list, 2, 3, 4, 5, 6, and let's leave 7, 8, 9, 10, 11. Okay, we have this sorted list. Now what we need to do is, let's say the number is 7. We have to insert 7 in the right place. So this is the right place for 7. So we have to insert 7 over here so that the list stays sorted, right? This is what we have to do. So what we can do is, for this, we do, and yes, for this we don't have to use recursion. The recursion questions were up to question number 10 only. From here, this is like general question. You can use anything. If you want to use recursion, you can use that. If you want to use uh, what is it, normal loops, for loops, while loop, normal list iteration, you can do that as well. So can any one of you tell me how will you handle this?
So in this, we have to insert it at indexed place or in the sorted manner. Like we
Yes.
have to insert 7 at the index 7 or in the sorted manner.
Yes. Well, it can be any number. We just and it can be any index. We have to store it in a sorted manner. So for this, what we can do is, one method that that is coming into my mind right now is, we can just iterate over the list. We will first make an empty list, okay, and then we'll iterate over this list, the original list, and we'll keep iterating until we encounter a number greater than 7. Like if the number is smaller than 7, let's say we have a empty list. This is one empty list, okay. This is our new list. We'll call it NL. This is our new list, and then we'll just iterate over our old list. We have this number. This is less than 7. We'll add this. Now we have 3. This is less than 7. We'll add this. So all the numbers which are less than 7, we can add those, and then we have this place of 7. But 7 is not here, right? Originally 7 is not here. We have to insert 7 over here. Now after 6, we will encounter 8. Now the point where we handle any number which is bigger than 7, then we will insert 7, and then we can insert the other numbers. We can do this, right? So this is one thing that I can think of. Now anything other than this, let me see if we can come up with another idea. I don't think so. This is the most simplest thing we can do. So now let's try to do this. Now what we'll do is, we will make a out list, which is another empty list, and then we'll just go for lm in L. So for every element in this list L, what we will do is, if lm is smaller than our this x, if the element is smaller than x, then what do? We just go out dot append this lm. We will append the element. Else, if the element is now bigger, what we will do is out dot append. Now we'll append x. But this will not work. Why? Because what will happen is, if we have numbers which are less than x, it will append that. So the left side will be fully sorted. Now, the moment we find a number which is greater than our x, right, which is greater than 7, this will actually append 77777. So we just have to append 7 once, and after that we have to append normally. So we will have to make a flag of some kind to check if
We
we
can use
have
recursion,
inserted
no?
an uh-huh.
We can use recursion.
Recursion for this.
Yeah,
How come? Can you like think of any way?
yeah. What we can do is the base case will be if length of L equal to 0, then we'll return x, the element x, and else if x is less than L of 0, then it will prepend x to the list. Else
Can
it
you
will.
please write the code? Can you please write the code?
Okay, I think it is.
Yeah.
What is it
Please
one?
write the code and send in the chat box. Yeah. So what we can do is we can have a flag of some kind. Let's say inserted over this. Let's focus over here. So initially inserted will be false, which means we have not inserted yet. Okay. Now in the else condition, we will have another, that if inserted, right, if we have already inserted our x, then we'll go out dot append normal elements, which is lm. Otherwise we will go out dot append x. Make sense? Wait, so over here, else if inserted out dot append lm, if inserted is true, we will append the element. Else, let's write another else block over here. We'll append the element x which we want to add in the middle, and we'll go inserted is equals to true now. So this should work, and at the end we'll return the outlist. Let's see if this works. So 1 2 3 4 5, we have to insert 4. Expected output is 1 2 3 4 5. Actual output is 1 2 3 4 only. Okay, there is no 5, so we have to insert 5 as well. Let's see. 5 is not working. For 5 it is not working. 5 is greater than x, so it will jump in this else condition if inserted out dot lm. Let's simplify this a bit. There are multiple if conditions. Let's simplify this.
Sir, I have pasted my code.
Okay, so if length of L is 0, we'll return x. If x is L0, okay, if x is less than L0, we will return x plus L. Otherwise, we will return x plus L0 insert. Okay, let me see. Let's see if this works. I'll do this, and I'll do this. Your function is not recursive. Okay, so case 1 passes.
This is for case 1.
So if length of L is 0, which means we have no elements in L, we will return x. If x is less than L0, which is if x is less than the first element of L, we will add L over here and we'll do this. And yes, we will return L0 and plus insert L1 and then x. Yes, yes, yes. This is fine. This works. So basically what we did is, what we are doing over here is this, right? So in Kiran's approach, what we are doing is, let's say we have the same list, 2, 3, 4, 5, 6, and then 8, 9, 10, and we have to append 7 over here. We'll share this tab. And let's copy the code. This is the code. And let's get this is fine. So basically what we are doing is, if the x is smaller than the first element of L, right, we are returning x plus L. But over here our x is not smaller than this, right? Then what we do, we just write 2 over here. We just have the first element of the list over here, and now we pass this list as a you can say sub list to check whether s is smaller than this first element or not. If 7, since 7 is not smaller than this, we'll add 3 over here as well, we'll add 4 over here as well, 5 as well, and then 6. Now that we finally have 8 over here, which is this is the sub list. Now 7 is smaller than 8. So what we will do is, if 7 is smaller, this is the case, then we will add x and then the whole list. Okay, so we will add 7 and then the whole list, which is 8, 9, 10. 8, 9, 10. So this is the let's move it over here. Okay, so this is the code. Now let's move on to the next question. So a recursive function to sort the list L. Now we have a list and we have to sort it in this manner actually. So we have to use this insert function to sort this list. So this is, now if we write both these functions, we'll basically write the whole loop. So what we need to do is, let's say we have a list. I'll copy one list from the test case. I'll copy that list. So this is the list, and we can delete this. Okay, the flow will be basically we will just go on to the last element when we have only one element, or we can go from either side. Okay, we can go from this side or this side, whichever side is fine. So what we need to do is, first we will append the first element, whatever is the first element in the list, we will append that. So this is 1. Now we will append 5 over here, we'll insert 5 in the same list, since 5 is bigger than 1. Now 4, where will 4 be inserted? 4 will be inserted over here between 1 and 5. Where will 3 be inserted? Between this 1 and 3. This is the right place. Where will 2 be inserted? Over here. I'll make it less cluttery and let's write this. So 1 is inserted, 5 is inserted. Now 4, it will be inserted between 1 and 5. So 4 over here. 3, it will be inserted between 1 and 3. 2 will be inserted over here. So we just have to use the insert function again and again to find the correct place. The insert function which we just wrote, we just have to use that. Now, since we want to make the function recursive, we have to find a base case. So we will move on to the we will basically move on from the when the list only has one element. Okay. So if the list only has one element, which means if the length of L is equals 1. So if the length has if the list has only one element, which is, so then what will we do is we'll just return L. Otherwise, if there are more elements, we will return I sort inside this I sort, right? We will no, not I sort. We will call this insert function. We will insert this. We will use this insert function, and in the first element, insert takes the L, which is the list. So in this list, we will only pass the initial elements. We will not pass the all elements. We will pass only the initial elements, which is this. We will not pass the last element. And then we can say that add the last element, -1. So basically we are saying that in this list, right, in this list, just leave the last element and add the last element at some place, at the correct place. So this is what the insert function is doing. Now we have to use the isort function as well. So basically what has happened is, if we go on there in this, share this tab, what has happened is we took this list and this was the element that we inserted. So now 2 is over here, 1 2 5, right? So this 2 from here, it has moved over here because this is the right place for 2. Now we have to do this for 3 and we have to do this for 4 as well. So to do that, what we can do is, wait, which tab I'm sharing? Yes, correct. Okay. So for this, what we have to do is, we will first sort the initial list, right? And then we will add 2. So if we sort this list and then we insert 2 over here. So this is how it will look like if I share this tab. So before inserting the correct element, we will do this. We will sort the inner list, right? I sort the inner list, which is L minus 1. L minus 1 is the list excluding the last element. So this is the list without the last element. So we will sort this list and then we'll insert this last element to this the sorted list, the sorted L1. Which term should I use? Let's call it the sorted list, and this is the last element. So we'll add the last element to the sorted list. So basically now the workflow looks like this. Let's say this, we have this, let's move this. So now the workflow looks like this, workflow or the code flow. So we are taking this we are taking this list. We're taking this whole list. Wait,
Sir, you are sharing the GRP of that.
yeah, just a second.
Now it's visible.
So if I have, so basically, I take this list. I don't want to fill. So if I can keep the background as this, I guess. And if I do this, this is nice. Yeah. So I take this list, I sort this list first, and then I add this to this. Okay. Now to sort this, what I do? What do? I take this part and I sort this. So to sort this, what do? I just take this and then I just take this one element. Now, since we have written over here that if L is 1, then we return L. The length of L is 1, which is one only has the list only has one element. We will return this. So from here we return 1, right? So from over here we return the first element, which is 1, and then we insert this 5 in 1. This is the code flow, right? We have this isort inside, and then we have the insert function. So now we insert 5 to this 1. So the correct position of 5 is over here. So we'll insert 5 over here. Now in this 1 and 5, what do we insert? We insert 4. Which is the correct position for 4? Over here. Now we insert 3. Now we insert 2. This is how the code flow will be. Got it? Any issues in this one? This one was actually a bit kind of confusing.
Yes, sir.
Okay, fine. Let's move on to the next question. PPA 12. Okay. So polynomial is a mathematical function of the following form. So this is the form. AIs are called the coefficients of the polynomial and uniquely determine it. The polynomial can represent Python using list of coefficients. Now Li corresponds to the coefficient Ai of xi. Write a recursive function named poly that accepts a list of coefficients L and the real number x0 as argument, and it should return the polynomial evaluated at x0. For example, 1, 2, 3 and 5 should return the value 1 plus 2 into 5 plus 3 into 5 square plus 86. Okay, so in this question, we basically have to make this series. We will have A and we will have X, right? We will have A0 and we will have X. So the A0 is already given to us, like the A list is already given to us, and we have a X0. So for this, what we can do is we can just do this, like we can write a, we can return basically. So I'm not writing the whole function, I'm just giving a what is it, a brief of how we can actually do this. So since we have a list, then we cannot do it. If we have a list, then we'll have to iterate over the list. A पे power x into 1, A2 to the power x into 2, 5 square and then 86. So yeah, got it. So if we break this down, this is basically something like this. Let's say we have a1 into x naught by power 0 plus a2 into x naught power 2 plus a3 into x naught power 3. So we just have to calculate the sum of this, and these a's are in a list. Let's say 1 2 3 4 5, and this x naught, it is given to us as a variable. So x naught is, let's say, 5. Okay, now what we can do is, yes, someone was saying something, I guess.
I think we haven't shared the screen.
Your voice is very low.
I think you haven't shared the screen.
Yeah, yes, I was
Thank you.
sharing that. So this is the equation, right? This is the equation that we have to solve, and the a list is given to us and x is given to us. The factorial that we want, not the factorial, the x value, which we have to continuously use as exponentials, and we have to write a recursive function. So what we can do is, for this, what if we just have, let's see, what if we just do 1 plus polynomial of this. Yes, we can do this. 1 plus, and then we'll just multiply x. So whatever x we have into polynomial of this function. So 2, 3, 4, 5. We can just go poly of 2, 3, 4, and 5. So in this poly of 2, 3, 4, 5, what it will do? It will do 2 plus x into poly of 3, 4, 5, right? Poly 3, 4, 5. So if we solve this, let's not expand this poly 3, 4, 5. Let's just solve this. This will basically be 1 plus, since we have a x over here, x into 2 plus x. So 2 plus x into poly 3, 4, 5, something like this. So it will basically be 1 plus 2x plus this x into x is x square, and poly 3, 4, 5 will give me 3, and then poly of that, right? Poly of dash dash dash. So see, we have this 1 and then 2x, 3x square, 4x cube. We will continue having that. And when do we stop? We will just stop when we only have one element in the list. So if we only have one element, we will just give that element. Let's say, let's just expand this. We erase this whole thing, and let's expand this, and let's remove 5 as well. Let's do only till 4. So after this, that is, let's erase this as well. Yeah. So after this 2 plus x into poly 3, 4, we will have 3 plus x into poly 4, poly 4. And since we only have one element, we will just return that element 4. So from over here, we will have 3 plus 4x, right? And then it was multiplied with x. So we have this x. And then we had 2 plus. So 2 plus. So the result of this will be 2 plus 3x plus 4x square. 4x square, right? So this is the result for that one. Now we will take this result over here. We'll take this result over here, and then we'll multiply it with 1 plus x. So we'll just have 1 plus x into this. Let me just erase this line, and we'll have this. So 1 plus x into 2 is 2x, plus 3 into x is 3x square, and 4x square this 4x cube. So this is what we wanted, and if we substitute the value of x, it will give us the solution. So we can do this. Now let's write the code for this. So basically, if length of L is equals 1, if the length of L is 1, we will return L, we'll return the list. Otherwise, what we will do is we will return L0, the first element of L, plus x0 into poly of, we will have this, okay, poly of L minus 0 and x0. Let's see if this works. 0 out of 5 privates passed. There is one error. Unsupported operand type of plus int and list. So somewhere we have a integer and list problem. So this should be an integer. So basically it means that from here we are getting a list. Let's see. Yeah. So basically we have to return the first element. We don't have to return the whole list. We just have to return the element from that list. That's why we were having the issue. Now it should be clear. Yeah, 5 out of 5 cases passed. Any issues in this problem? idx equals to len minus 1. If length of 1 is 1, we return 0. If otherwise, we do L minus 1 x into idx. Yeah, that also we can do. We can have a counter, and from that counter we can we can increase the counter and just do that. Yeah, this is also doable. Result is 0 if len is this for I in range. But Kalyani, we were supposed to make a recursive function, right? That was the whole point. See, right? A recursive function. Oh no, wait. At the end, you have a recursive call for I in range of L0.
Yeah, I tried to make I in range of len L. It gave me error.
Yeah, because what you're doing basically is, if I copy your code, I'll tell you your mistake. Let's comment this out and paste this. So what you're doing is, first you're saying that result is 0, and if length of L is 0, you're returning 0. Nice. Else, if length of L is not 0, you are iterating over over the range L0. But let's say this, let's just take the value of the first test case. We have 1 2 3 1 minus 2 3. Let's say we have this 1 2 3. Okay, let's say the input is this. And this 1 2 3 I'll make 10 2 3. Let's say this is RL. So over here you're just doing range of L0. L0 is 10. So you're doing range of 10. Porine range of 10. So this will, the value of I, it will start from 0 and it will end at 9. So you will get all the values from 0 to 9. And for all the values, what you are doing is, you're doing this. L0 into x0 pe power that.
Okay, so it should be for I in range len L, right?
For I
Or
in
no?
range length of L. So basically what, if you go by this method, you don't need a recursion call. If you
Okay.
remove this recursion call, and if you do this for I in range length of L, you can just go Li into x to the power I. This will give you a correct result.
Okay.
This should give you correct result. Okay, no.
Okay.
Let's try. If I remove this
Okay, guys.
and let's just have I. Let's see. And we have to return result. Return result. Let me see the output by. I know the function is not recursive, but let me see the output.
Because with this code, first test case was passed.
Yeah, there's no output. Okay, let's remove this. You have a result is length of 0. And in this, you don't even need this. Like this length of 0 check.
Okay.
You can just go for I in range of length L, result equals to Li into x0 into I.
Okay.
And not result equals to. This should be result plus equals.
Okay.
They're not letting me see. Never mind. Now let's move on to the next question. Next question is power. Write a recursive function named power that accepts a square matrix A and a positive integer m as argument and returns a to the power m. So over here we have to multiply two matrices. Is this a recursive function? Yes, we have to write a recursive function for this. So for this, what we can have is we can uh, the matrix is always a square matrix, right? So and we have to multiply it n times. So for this, first of all, let's write another function which will actually just multiply two square matrices. Okay, def ti multi. Let's say this will take a comma b, and it will just multiply those matrices. So matrix multiplication is basically first you'll have to make a empty matrix. I think let's say dy. Empty is equals to an empty matrix, or we can just go out because it will not stay empty all the time. And over here we just write the code for this. For I in range length of A, for j in range length of B, and it could be A because these are both square matrices and they should have the same order as well. And then for k in range length of A. So for ijk, the value of aij, we'll have to first make a zero matrix, and then only we can do this. Before making a zero matrix, is it possible? Let me see. Hmm.
We can write a result equals to inside a list 0 times.
Mm-hmm. Come again, please.
We can write a variable result equals to inside a list 0 times
Yeah,
the
we
number
have
of
to make a zero matrix. Yes. So let's make a zero matrix. So basically, in this out matrix, we can just go 0
times.
0 times.
No, outside this.
Yes. Basically, 0 times length of A, and this whole thing should be repeated
In range of
this. Yeah. For I in range length of A. Length of A. This should give me a zero matrix. And now that we have a zero matrix, we can use that. So out ij will be ik into ikj. So yes, out ij j will basically be is equals to
plus
plus
equals
equals
to.
to, yes, plus equals to out ik into not out ik, aik,
Okay, I can.
and b kj. Kj. Yeah. So this should be this is the code for multiplying two matrices, and it will return out. Okay. Let me just cross check. So 0 into length of A for I in range length of A. This is, I still find this skeptical. Just give me 1 minute, okay? Yeah, this will work. So now that we know how we can multiply two matrices, we just have to multiply it m number of times. So basically, if m equals 0, if we have reached m equals 0, yeah, Kiran has actually sent the code for us. So I'll take some of Kiran's code. So basically, if not 0, if m equals 1, if m is equals to 1, we will return a, just a. Otherwise, we will return this multi. So we will multiply a and power a into m minus 1. So basically, if we have to calculate a to the power 5, over here we are calculating a to the power 4, and then we are multiplying a with it. That's what we are doing. Yeah. So we could have written this function inside this, but that will not make sense. This is making much more sense, that this is the function for multiplying two matrices. So over here we are just multiplying, we are using the multi function to multiply these two matrices. The first matrix is A and the second matrix is A to the power m minus 1. Okay.
Excuse me, sir.
Yes.
So I wanted to ask a question not regarding this, but what is the syllabus of OPP2?
The syllabus of OPP2 is just the whatever was the syllabus for OPP1 plus one file handle. That's all.
Sir, thank you.
Now, I think in this we have to calculate the determinant. If you have grasped the essence of recursion, then you would the simplicity of the whole idea to solve this problem. Maths 2, and maths 2, blah blah blah, square matrices. Write a recursive function named det that accepts a square matrix as argument and returns its determinant. In this process of writing this function, it will be useful to look into GRPA 3 of week 7. A good approach would be to write two functions, det and minor matrix. Why are they telling us to go to look GRPA 3 of week 7? This is for Manhattan distance. Let's not waste our time and let's jump on to question number 14. It was right. Yes. So now we have to calculate the determinant. So determinant, is it similar to matrix multiplication? I think it is not. So in determinant, what we do is basically if we have a matrix like this, so it is given over here. So if you have a matrix, we do minus 1, 1 plus 1 into a into determinant of this, and then into determinant of this, and then that. So as mentioned, as the hint is given over here, we will make two functions. First is determinant and the second is minor matrix. So for every element, we will first calculate the minor matrix. Minor matrix of m or n. So first we'll calculate the minor matrix, and in minor matrix, so for minor matrix we will actually need the original matrix and we'll need the column. Okay, so determinant of m matrix is as follows: AD minus PC, and recursively as follows. So for any n cross n scale matrix, its determinant is defined recursively as follows. So summation of j0 till n minus 1 minus 1 into j into m0j into mj. Here mj is the determinant of the matrix obtained by removing 0th row and the jth column of m. Here we have used zero based indexing. These does not make any sense.
Basically, we are creating minors of 2 cross 2 from 3 cross 3 matrix, and then then multiplying them and calculating determinant. This is everything.
Yes. So we have to calculate minors of everything and we have to multiply. So I am just trying to figure out how will we go on about this question. I am just getting ideas of loops. I am not getting how we can calculate the determinant for this one use recursively.
We can write the function for the minor, and we can call it in the determinant. We can call the determinant for the minor matrices.
We can call the determinant for minor matrices.
And we can give the base case for length equal to 2.
Okay. Yes, that
can
makes
use
sense.
this formula, determinant of m equal to minus 1
that makes sense. That makes sense. Okay, so what we'll basically do is, so let's have a first let's have a minor matrix. So for minor matrix we will first let's take the n, which is length of m, and let's take a out, which is an empty list by default, and then we'll just have a for loop that for I in range for I in range length of m. Okay, so we have already taken length of m. So for I in range n, and since we have to take a minor and then we have a column information, yeah, since this is a matrix we'll need 2.
I think we have to create a list of list.
Yeah, we'll have to create a list of lists. That's why we'll have another list over here, and we'll have another loop for j in range again in. Now what we do is, if we have a minor
should be for j in range n plus 1.
wait, let me actually let's make a determinant over here. Let's make a matrix over here. Okay, let's have 1 2 3 4 5 6 7 8 and 9. So if I have to calculate the minor for this one, we have to leave this column, and this row, and basically this will be the minor of that matrix, that element, sorry, it will be the minor of that element. So basically what we do is we take the whole matrix, and since we are calculating the minor for this, we can have the column information of this, like this is the column of this, and if Let's actually look at the formula which was given. Okay, so we can start. Actually, we can by default, since we are just writing this for this particular question, and we know that we will only be using this first column, the first row, to multiply. What we can do is we can by default kind of hard code that we are going to ignore all the elements of this row and all the elements of this column. So this column is basically the uh, column we are taking in the minor function. So basically what we can do is over here we can start the outer loop from 1 so that we never have the first row. Okay, and j will be normal, and inside this I can write one condition, that if j equals col, if we have the if we are in the column of that particular element, we have to ignore, or we can just write continue. If j is in column, we will continue, otherwise we will go temp dot append m ij, I and j. Yes, I think this will work. And otherwise, like after finishing this loop, we can just go out dot append temp. Okay, so basically what we are doing is we had this matrix. Let me just remove the unnecessary rows. Okay, suppose this is the element we are finding the minor for. We will ignore this whole row. The first row we are ignoring anyways. That is why we have the we have this condition, right? Since we are ignoring the first row always, we will start this outer loop from 1, not from 0. And then for this element, what we do is we have ignored this row, so everything will be ignored. And since this is the column for this, we will ignore the column as well. So that is why we have written that if j equals column, we are continuing as in we are not appending that element. Or instead of this, we could have written something like this. We can remove the continue statement, or we can just go if j not equals column, then append. If it is equals column, then ignore, then don't do anything. We can write this as well. And then we will just add this and this. So if we repeat this for all the elements, this and this, we will have the minors for this. So now in the determinant function, we just have to go and multiply 1 with the minor of 1, minor of 1, 2 with determinant of minor of 1, 2 with determinant of minor of 2, and 3 with determinant of minor of 3. We just have to do this. Let's return the minor matrix, return out. Now in the determinant function, we will have to write the base case for it, that if len of m equals 2, if the length of m is 2, we will have to write the base case. So the base case will be first element, then the rightmost, the bottom right element. So basically we return m 0 0 into m 1 1 minus m 1 0, right?
Zero.
First row, 0th column into m 0 1. So this is the determinant of a 2 cross 2 matrix. Now otherwise what we do, otherwise we have to now calculate the this, what do we say, the determinants of all the j columns, like all the elements. Basically we have to now do this. We have to consider any column. We can take this, this and this. Let me just, let's make another matrix so that it looks better. So 1 2 3 4 5 6 7 8 9. So now that we have the minors, what we can do is we can just iterate over this, this and this. Okay, we can iterate over this and we can have 1 into minor of this, 2 into minor of this, and 3 into minor of 3. We just need that and we add all of that. So kind of we have to just write this loop now. We just have to write this loop. Whatever is written in the sigma function, we have to write that. So what we can do is we can have a sum like determinant. Yes, determinant initially we'll consider it 0, and now we can, I think, use loops. Or is there any method to do this recursively as well? Let's use loops, because we have already, inside the loop we'll be making recursive calls. So for j in range, length of m. So for j in range length of m, determinant plus equals, determinant plus equals j 0 1 2. It will be 0 1 2. So initially we have to do this. We will just do this. So m j, m of j into determinant of minor of m of j. No, in the minor matrix we are passing two things, m and the column. So the column is j column. So mj into determinant of this mj and into, now we just have to figure out the signs. So -1 to the power j, -1 to the power j, or it should be -1 to the power j plus 1, I think.
-1 to the power j.
No, it will not directly be j, because we are using a 0 based index. Zeroth, here we have used 0 based index. So if we do -1 to the power 0 for the first one, it will be 1, and then -1 to the power 1, it will be -1. Yeah, so I think we can just directly write -1 to the power j.
This is only for the symbols, like for odd one it's -1 and even.
So I think this is done, most probably. Let's see if this is done, and then we'll return determinant. Let's test run this, and hopefully there are some issues. unsupported operand type int and list. So somewhere we are doing another mistake.
Won't it be m of 0 of j in the determinant?
Where?
In the 28th
Line number
line.
28. 28.
Line number 28.
M of 0.
M of 0 of j, right?
Yes,
M
sir.
of 0.
Yeah, m of the first row and
Yes,
element
yes.
of the first row.
M of 0. Yeah, got it. Expected output was 5, but actual output is 7. Let's see if we have made any mistakes. Uh,
What
uh,
if the matrix is 1 cross 1?
mhm.
If matrix is 1 cross 1, like
What if a matrix is 1 cross 1? That is just one element. That is not even a matrix. The issue is the determinant should be 0 and the actual output is 24. How is it coming 24? Let's see. If we have this 1, 2, 3, 4, 5, 6, and 7, 8, 9, so it will go over here. So for j in range length of m, so for j in range length of m, I think there are some issues with this. Minor matrix, I think it is fine. Let's see if the minor matrix is fine. Instead of doing all this, can we just print the minor matrix of n column number 2, let's say. If I just do this, let's see what happens. The function you have written is not recursive. Let me see the output by. Let's do this. Let's not return this, but let's do this as well. And also let's do this. So this will pass the recursive check, and I just want to see the minor matrix of this. So the minor matrix is minus 1, 2, 0, 1 of row number 2. So 0, 1, 2. Row number 2, it is minus 1, 2, 0, 1. So the minor matrix is correct. The minor matrix is coming correct. So there is no issue in the minor matrix. The issue is, I think, with this. In the determinant of 0. This is also fine. M00, M11, 1001. So this is fine. For j in range length of m, determinant plus equals m of 0j into determinant of this. The first element, that should be positive, right? Wait. Yeah. So the first element in determinant, it should be positive. So minus 1 into 0. Minus 1 to the power 0, it will give me 1. Minus 1 to the power 1, it will give me minus 1. And minus 1 to the power 2, it will give me 1. So this also looks fine.
Sir, can you write this part uh, -1 to the power j before the before this?
Like
Like
before
first,
this.
like first -1 to the power j times m0j times determinant of minor.
Since everything is multiplication, it should not be an issue, but let's see. Or what we can do is we can have a bracket over here to
Yes.
separate things out. Okay, let's return the determinant. We are not returning it. Still there are issues. What if I do j plus 1? Let's see. If I do j plus 1, j plus 1. The output is same. What if I do j plus 2? The output is still same. So uh, this is correct. This has no errors. Let's see the formula once. So for j0 to n minus 1, yes, that is correct. I to the power j into m0j, I to the power j into m0j into mj, where mj is the uh, minor, determinant of minor. Let's see if this is coming correct. Instead of returning this, let's print this. Let's print this. So we are getting 2, -3 and 1. So the determinants are 2, -3 and 1. And if we multiply 1 into 2, that is 2. Let's first manually calculate the determinant. Let's do it for this matrix. So -3, -6, and then 3, -3. Let's manually calculate and see if this is correct. So for 1, it will be 5 9 are 45 minus 8 6 are 48. So 45 minus 48. This is -3. This is correct. And for this, it will be 9 4 are 36 and 7 6. 7 6 is 42. So 36 and 42. 36 minus 42. This will be 6 minus 6. And 8 4 are 32 and 7 5 are 35. So 32 minus 35. So 32 minus 35 is -3. Yes, so the minors are correct. The determinants, this part is also correct. The issue is with this. Let's just see. After this, let's print the determinant each time.
Sir, I have pasted a code. Can you check it for this line number 28, replacement for that?
Okay, so you have pasted 3 lines actually. Okay.
Actually, sir, so this double star should be outside of that bracket, I think.
Yes, most
This is
probably.
not the.
Let's see this. minus 1 to the power j. Let's. Okay, we are printing. Let's not print. Yeah, this is fine. Okay, so the issue was this. It was taking the minus as the whole power and then minus. So that was the
Yes,
issue.
yes.
Oh. It's so anyone have a do you have any issues with this question? This was actually tiring. Just one parenthesis to call the time.
Sir, can you show the code again? The previous.
Yeah. This parenthesis took all the time, right? Okay. Now let's just finish this 15th PPA, and in the next session you can ask the instructor or the TA to take this the GRPS of week 9. Okay, we have a locker that has finite number of coins, and each coin has some positive integer that is engraved on it. This denotes how valuable the coin is. You wish to draw a subset of coins from the locker whose total worth is S. The task is to determine if this can be done with the coins available in your locker. Write a recursive function named subset sum that accepts a list of positive integers L and a positive integer S as argument. The list L represents the coins in a locker, and the integer S represents the total value of the coins that you need to withdraw. Return true if you can withdraw some subset of coins whose combined worth is S, false otherwise. So basically, here we have some coins, right? We have a list of all the coins, and there's also a value associated with them. There's also a value that we need to achieve as the sum of coins. Let's say the coins are this. Let's just open the test case, and let's say that this is the coins, and the value that we need to achieve is 6. 6. So this is possible. We can have 5 plus 1 6, or we can have 4 plus 2 6. Let's check a false case. So this is a false case. So because we cannot use these coins to make a sum of 21 rupees.
We can use only two coins.
No, we can use any number of coins.
Okay.
I think. Let me see. The integer represents the total value of the coins that you need to withdraw. Can subset of coins. If you need a hint, come to Discourse. You do not have to accept the input from the user. Okay. So I don't think we need to use only 2 coins. Yeah, we don't need to use only 2 coins. It is not mentioned anywhere here. Okay, so
Basically,
what?
we have
Mhm.
we have to check all the values of the coins, or check whether they sum up to the 21 or any other number. Or
Yeah, the sum of any other number can achieve 21 or given number or not, and that we have to do recursively. Oh, let's see what we can do about this one. So what we can do is, let me share this tab, and let's say we have some coins, x1, x2, x3, x4, and x5. Let's say we have 5 coins. So basically, and let's say we have to achieve a sum of s. So what we can do is we can recursively check. So first, we'll just take any coin. Let's just take any from the start or from the end. Let's take from the end. Okay, we take this coin and we just subtract with this s minus x5, and now we just look for this value in this list, that whether I can make a sum of this using these coins now. So basically I am going in the reverse order and I am summing up all the coins. I'm doing something like that. Right. So basically what I'm doing is I take one coin and I just take the last element and I remove the last element from here and I subtract the last element from this coin, and I am checking whether I can make this new value with these coins only, excluding the last coin. I'll keep doing this until we have a negative value or we have an empty list. Right? We can keep doing this until we have an empty list. So at any point, if we encounter, if we just like if we achieve the required value, right, we can return true, and if we return true at any point, the recursive calls will be over, right? And if we like don't get the sum, what we will do is we'll just remove all of this and we'll just remove only the last coin, that this coin is not necessary for us, and then we will do with these coins only. We can try to achieve the value with these coins. And since we are doing it recursively, what ultimately will happen is, I'll tell you. Let's remove this and x5. Yeah. So since we are doing it recursively, we'll check first. We will check for this, whether I can make s minus x5 in this list or not, and here I'll check whether I can make s minus x5 minus x4 or not, right, using this list. And if I cannot make this, x5 will be eliminated, and now I'll check only with this list whether I can make the value of s using this or not, value of s using this. So I'll go s minus x4 in just this. So we are ultimately just processing all the possible sums in all the orders. That is what we are doing. And how do we know that we have achieved the value? That if s equals 0, if s has become 0, we'll say we have achieved the value. So we'll return true at that point. Okay. If now the next condition is if s has not reached 0 and the length of our list has become 0, then we'll return false. So these are two base conditions. Now we will check that if subset sum of L till -1 and S minus L minus 1. If this is the case, we will return true. Okay. Otherwise, what we will do is we will just do this, that if else, like if we are not able to make this sum using the last element, we'll just go else return subset sum of L minus 1 and then S. So this is how we can do this problem. Let's see if this works. Yeah, this works. So basically we are doing that in this, if subset sum of L minus 1 and S minus L minus 1 is true, we will return true, and else we will return like if we can make this if we can make the sum using the last element, like we will use the last element and subtract with all the elements. If we can make a sum like that, we will return true, else we will just remove the last element and try to make the sum using the other elements. Any issues with this one? This one was a little confusing as well.
Sir, can you explain it once again on the?
Yeah, sure. So basically, I'll copy the code. I'll paste the code over there as well.
Yes.
And then we'll just text. Let's change the color to white. Okay. So let's say this is the list. I'll take the list from there as well. And let's say this is the list. We'll change the color of this list. And the sum we have to achieve is 6. In this, we have to achieve the sum 6. So what we do is, if S equals 0, in this case, S is not equal 0 right now. So we'll ignore this. If length is 0, length is not equal 0, we will ignore this as well. Now we'll try if subset sum of L minus 1, S minus L minus 1. So basically we are doing, just give me a second, okay? So we are subtracting this. We are just doing this. If subset sum of L minus 1, so we are removing this element, and S of L minus 1, S minus L minus 1. So L minus 1 is 5 and this. So 6 minus 5 is 1. Now, if we can make a sum of 1 with these elements, we'll return true. Otherwise, we will just remove this element to see if we can make that sum or not. So now in this question, now this has passed. So this whole list up to 4 and the new sum is 1. Right? the new sum is 1. So over there we have another this called the subset sum of this. Now this is our new list 1 2 3 4 and this is our new S1. So we'll check again. क्या S 0 है? Is S equals 0? No, S is 1. If L is क्या L 0 is the length 0? No, the length is 4. So we'll return not return false. Now if subset sum L minus 1 S minus L minus 1, if this can be done, we'll return true. So now again we will subtract 4 and this. So we'll now subtract 4. But we cannot if we subtract 4, it will be minus 3. So we will go till this point and this will actually call this now 1 2 3 and then this minus 3. So we'll just subtract 3 over here. This will be minus 6 and then 1 2 3 and then minus 6. So this will go keep on going. So this will be minus 2 will be minus 8 and then minus 1 will be minus 9. And since the list is now empty, what happens is we will return false. Okay, now this initially returns false. So from 1 it will return false, right? From 1 it returns false. So what happens is it will return false. So this part will be false and will then go on move to the else condition. So in else condition, what it will do is it will remove the last element and it will search for S. So it will remove the last element. So let's see, this was the list. It will remove the last element and it will remove this as well because this is never done. So it will now try to look for 6 in this part only. So basically what everything will be undone up to here 3 and then we are just removing one element, you can say, from the middle and we are searching for that. If that is also not doable, we will remove one more element because see, this is trying to calculate the sum with subtraction. Sum with subtraction, that is so bad. So this thing over here, we are calculating the sum. We are basically checking if we can calculate the sum. If we cannot calculate the sum, we will remove one element. If the subset sum, right? If we can have a sum with this subset, we will return true. Else we will return one element and then we'll check whether we can make the subset or not. Got it? Okay. Any issues in this question? Okay, if you still have issues, what you can do is you can like take some time and try to understand the code yourself. Okay.
Okay, sir.
No, I did not mean it like that. Sorry, that came out very bad. So what I was trying to say that if you are not able to understand it, right, you should like think about it. What actually is happening? Try to do it yourself. to the copy and pen, like just dry run this code for this 3-4 element list and just see how the flow is going. Okay. Now, before ending the session, any other doubts apart from this question?
Sir, I have doubt in the week 5 GRPA.
Week 5 GRPA. Which one?
Sir, GRPA third.
GRPA third. Okay. Week 5 GRPA 3 composing functions. This one.
Sir, can you please tell me how to solve, what I have to do in this question?
Like, there are multiple questions. You just have to solve everything. So the first one is index of first occurrence. So given a list, find the index of the first occurrence of one in it. So you just have a list and you have to find the index of one at whatever index one appears first. You just have to find that index of last occurrence. In this, you have to find the index of last occurrence of one. Let's say we have a list like this. Let's say we have a list like this: 1 2 3 4 1 1 0. Okay, so the first occurrence is this is the first occurrence, right? So the index will be 0. Last occurrence is this, and what is the index of this? 0 1 2 3 4 5 6. So the index of first occurrence will be 0, last occurrence will be 6.
Okay, sir. Sir, and in GRPA fifth,
I say similarly, you
grouping,
just have to solve all the other questions. Yeah, in GRPA 5th,
sir, grouping part, in the grouping part, how, can you explain me the solution of first test case?
solution of first test case. This group by thing.
Yes, sir, here group equal to key item. What is this?
Group equals to key item. Where? Can you tell me the line number?
Line number 24.
Line number 24. This outdict key item.
Sir, GRPA 5.
GRPA 5. This is GRPA 5. Of which week? This week, right?
Sir, yes, sir, week 5.
Week 5, GRPA 5, and this is the solution. Okay, so this is the solution. Line number 24. Group equals to key item. This one, right?
Yes, sir.
So key is basically some function which is being passed, right? If you see the test case, the first test case is in this group by lambda. So this is the function x equals x naught.
Okay, sir.
Okay, so this function is being passed. So if you like know about lambda functions, this is basically giving out the first letter,
Yes, sir.
right? It is basically giving out the first letter. So if we do group equals key item, key is the same lambda function, and in
Okay,
that
sir.
lambda function we are passing in the item. So for item in data, in that lambda function we pass the item. What
Okay,
was the
sir.
lambda function giving me? It was giving me the first letter.
Okay,
So
sir.
group is basically the first letter of whatever item is being passed.
Thank you, sir.
Yeah. Any more doubts or questions? Okay, if you have no more doubts, I think we can end the session. Thank you for
Thank you.
joining. Yeah, thank you for
Thank you,
joining
sir.
everyone, and have a good night.
Good night.
Bye bye.